In this video, we're going to talk about the structure of the atom, namely the subatomic particles of protons, electrons, and neutrons. And by the end of this video, you should be able to pick any element on the periodic table and calculate its protons, electrons, and neutrons. So let's get started. In this data table up here, we're going to talk about two properties of protons, electrons, and neutrons. And if you want a little mnemonic that helps you out as far as memorize what's inside the atom, this is going to spell out the word pen. So P-E-N for protons, electrons, and neutrons. Now, understanding their properties will help you calculate how many protons, electrons, and neutrons are in a particular element. So let's start out with the mass. The two things that have mass are the protons and neutrons, and we assign them a value of 1. Now, the electron does have mass. However, the mass is so small that it's insignificant. It's kind of like saying, hey, if you had this automobile and then you put a feather on top of it, would it weigh more? Well, of course it would weigh more, but not significantly. Okay, so that mass of the feather, just kind of insignificant. So we are going to assign the electron to have 0 mass, but realize electrons technically have mass, but it's so small relative to protons and neutrons, and that is why we're assigning it a relative mass of 0. When it comes to charge, the two things that have charge are the protons and the electrons. Okay, and they're both going to be assigned 1. We put the positive sign after charge a lot of times in chemistry. So if you did it reverse, you did like positive 1, it wouldn't be a big deal. But kind of like the way we do things, we tend to put that charge after the number. And then if you want a little mnemonic here, proton starts with a P, so it's positive. Okay. Neutron sounds kind of like the word neutral, so it has no charge. Okay, or it's neutral. Okay, and then the electron has the -1 charge. Now, from this, we're going to do a couple practice activities. I'm going to give you the number of protons, electrons, and neutrons, and what I'd like you guys to figure out is kind of like what is the mass and the charge based on these properties that we just discussed. Okay, so let's go ahead and do a couple of these, and we're going somewhere with these problems. So let's go ahead and start out with, let's say I had a structure that had 3 protons, 3 electrons, and 4 neutrons. Okay, and I wanted to ask you the question of, hey, how much mass does this thing have, and how much charge does it have? So if you want to pause the video and answer the question based on this chart, you can, and then come back and I'll be explaining what's going on here. Okay, so let's go ahead and do that now. Okay, so as far as mass is concerned, remember the only 2 particles that have mass are the protons and the neutrons. We have 3 protons that each have a mass of 1, so that's 3. We got 4 neutrons that have a mass of 1, so that's 4. 3 plus 4 is going to be 7. Okay. Now we could call these atomic mass units, but at this level right now, we're not so concerned about the units, which you'll rarely ever hear me say. Okay. Let's move on to charge. Okay. The 2 things that have charge are the protons and electrons. The neutrons have no charge, so we don't even care if there's a million of them. It has no effect on charge. The only things that have effect on charge are the protons and the electrons. We got 3 protons that are each a positive 1. We have 3 electrons that are each worth a -1. So in the end, we got a positive 3 versus a -3. They're going to cancel each other out. That's going to give us 0 charge. Okay, so in this structure, it has a mass of 7 and no charge. Okay, let's do one more. And like I said, I'm going somewhere with this. It might seem a little easy. But let's say I had a structure that was 9, 10, and 10 as far as its protons, electrons, and neutrons. What type of mass and what type of charge would you get out of this? Same thing as before. The 2 things that have mass are going to be the protons and the neutrons. So we add them up, the protons and neutrons. It's going to be 19. And then as far as the charge, we're looking at the 2 things that have charge, which are protons and electrons. Protons have 9, electrons have 10. So they're not even. They're not going to cancel out. In fact, I have 1 more electron than I do protons, and electrons are negative. And if I have 1 more negative particle than positive particles, this thing's going to have a charge of -1. Now, I said I'm going to go somewhere with this, okay? And that is, when we look at periodic tables, they are not standardized. I've seen all different types of periodic tables. However, when you pull information off of these periodic tables, okay, there is a format that you're going to use, okay? So I'm going to do the first one, okay, and then I'm going to pause the video for the second one to see if you guys can do whatever I do with this first part with the second part, okay? First thing that I'd like you to kind of like write down, maybe in your notes, is that the identity of the element is based on the number of protons. Say that one more time. The identity of the element is based on the number of protons only. So in this case, we got 3 protons, okay? If I look up on my periodic table, I'm going to find the thing that has a 3 is going to be the lithium, okay? So we know that this substance is lithium because it has 3 protons. We call this number 3, we call that the atomic number. An atomic number always tells you the number of protons. And the atomic number and the atomic symbol always have to match, always. So we know that this structure that has 3 protons, 3 electrons, 4 neutrons, 100% is lithium because the number of protons is 3. Now, in most periodic tables, that 3 is not on the bottom. In fact, on this periodic table, the 3 is on the top. But when you pull information off of the periodic table, there is a standardized format that you have to put it in, and the atomic number always goes on the bottom and to the left. Now, on the top here, we're going to put in the mass number. And the mass number is going to be the mass of the structure that we're talking about. In this case, it's going to be 7. Now, on the periodic table, it's going to say 6.914, okay? What that is that's an average of all the different types of lithium that are out there, okay? All the different isotopes. And that's going to be a later lesson where we talk about the different isotopes. But for right now, you can kind of think of, like, I teach 3 classes. One class might have 20, and my other class might have 21, okay? Well, my class average is 20.5, right? Okay? But I don't have a half student in each of my classes, okay? So this number right now on the periodic table, just remember, that's an average, okay? But when we're calculating protons, electrons, and neutrons, they're whole things. You can never have a part of a proton or electron or a neutron. So when you get to the mass number, that has to be a whole number as well. And in this situation, with 3 protons and 4 neutrons, that mass number has to be 7, okay? Now, in the upper right-hand corner, we would put charge if there was a charge, okay? However, in this case, there's no charge, so we're not putting any number. So what I just did here for this first structure, I would like you to look at a periodic table and figure out, this second one, okay? And pause the video and then come back and check your answer. So if we're looking at our periodic table here, and I'm going to point to it and hopefully bring it a little bit closer to the camera, we're going to see that the element that has 9 protons, or atomic number of 9, is going to be fluorine, which has an atomic symbol of F. So once again, whatever the protons are, that's going to be the atomic number, and whatever the atomic number is, that's going to be your atomic symbol. In this case, 9 matches up with fluorine. The mass is 19, so we're going to put 19 right here. And the charge is -1, so we put a -1 in the upper right-hand corner. Okay, so this is how we go from protons, electrons, and neutrons to mass and charge, and then into its format. Okay, and then now what we're going to do is we're going to try to do all of that in reverse. Okay, because a lot of times you're given the periodic table, your teacher tells you, hey, calculate the protons, electrons, and neutrons of this structure, okay? And we have to work that in reverse. So let me go ahead and erase this and do a couple sample problems so that you can all understand. All right, so here we go. Let's go ahead and pick phosphorus. That's a good one. So if I look up phosphorus on the periodic table and look up its numbers, it has an atomic number of 15, and if I round to the nearest whole number, it has a mass number of 31, okay? And I'm going to leave this with no charge as our first problem, okay? So let's go ahead and calculate the protons, electrons, and neutrons for a neutral phosphorus atom, okay? So first thing that we're going to do is we're going to look at the atomic number, and we're going to write that down for our protons, because the identity of the element is going to be based on the atomic number and the number of protons. From here, we're going to figure out the electrons and the neutrons using some logic from the properties of protons, electrons, and neutrons that we already know. Let's start out with the electrons. I figure out the electrons based on two pieces of information: the number of protons and the charge, okay? When I look here, there's no charge, okay? So that tells me the number of positive particles have to match the number of negative particles. And if I have 15 positive particles, I'm going to have the same number of negative particles. Remember, electrons are negative, protons are positive, in order for those charges to cancel out to leave me with no charge. I'm going to use the same logic for the neutrons. I'm going to use the protons and the mass. Now remember, the only two things that have mass are protons and neutrons. So when I add these two numbers together, I should get a mass of 31. So if 15 of the 31 comes from the protons, then the other 16 have to come from the neutrons, because 15 plus 16 is going to give me 31. So that's how we're calculating the protons, electrons, and neutrons. Now let's do a what if, okay? What if phosphorus had a -3 charge, okay? Let's say this was the problem. How would this answer change? Well, the protons would have to stay the same because that's the identity of the element. The neutrons are going to stay the same because when you add those two numbers, it has to equal the mass, okay? The thing that's going to change are the electrons. How many electrons would there have to be in order to end up with a -3 charge? Well, if I have a -3 charge, that means there has to be 3 more negative particles than positive particles. If I have 15 positive particles, then it means that I'm going to have 18 negative particles in order to result in a -3 charge. Okay? Let's do one more problem like this so that you fully understand. Let's say I have something like potassium, and I look at potassium on the periodic table, and I look up its atomic number, and then I round the atomic mass to the nearest whole number, and it comes out to be 39 and 19. Let's go ahead and calculate these protons, electrons, and neutrons. Once again, the protons is going to be based on the atomic number, which is going to be 19, because that's the identity of the element. From here, we're going to look at the electrons and the charge. There's no charge here, okay? So the protons and electrons, they have to match. Lastly, the neutrons are going to be based on the number of protons and the mass. The mass is 39. 19 of that mass comes from the protons, so the other 20 have to come from the neutrons. 19 plus 20 will give us 39. Okay? Now, same thing as before. Let's do a what if. What if this thing was charged as a +1 ion? Okay? Well, the protons are not going to change. I can't just add another proton because that would change the identity of the element. Okay? The element is potassium. It has to have 19 protons. What's going to change again are going to be the electrons. Okay? If I have a +1 charge, that means I have to have more positive charge than negative charge. And if I have 19 positive particles, to end up with a +1 charge, there can only be 18 electrons. So I hope this has helped you calculate protons, electrons, and neutrons. And you can pick any element off the periodic table, look up its numbers, and if you know a little bit about the charge, you can add the charge in as well and recalculate the protons, electrons, and neutrons for things that are neutral or things that are charged. You will use this information, okay, when you are drawing Bohr models, which is going to be a lesson a couple lessons away. So I hope that helped, okay, for you to calculate protons, electrons, and neutrons for any element on the periodic table.